we have a velocity problem in here. So if a ball is thrown into the air with a velocity of 40 feet per second, its height in feet after t second is given by that function. So its height, they describe the function or you can say the equation they gave you that describes the height. Find the velocity when t equals to 2. So first of all, you have y equals to 40t minus 16t squared. So another way to describe this is calling f of t. This is a displacement function. The y stands for displacement, the t stands for time. So when t equals to 0, initially you have f of 0 that equals to 0. That means when time is equals to 0, the ball is 0 feet away from the starting point. All right, so that tells you the displacement. How many feet away, right? 0 feet away initially. The point is 0, the ball is 0 feet away from the starting point. So that tells you how many feet away. What about velocity? So velocity is equals to the rate of change of displacement, which is equals to the derivative of displacement, which is equals to y prime, or you can say f prime of t. So you take a derivative to find the displacement function. That is not given. We have to find it. So first, let's find the displacement function. I need a function, that displacement function. I need to find the velocity function. We have a function describes the displacement. I need another function to describe the velocity of the ball at any time. So let's do f prime of t. So we call this a velocity. That is f prime of t. So that is the same as y prime. We do limit as x approaches to, not x, they use t approaches to 2. So we have f of t, y2 minus y1. y1 is you just plug in the 2, divided by x2 minus x1. So x2, x1, you just plug in the other point, the second point, you just take two steps forward, t equals to 2. Initially, that you are at a point 2, right? 2. And then the next point is you want to take t steps forward. So that's why you have a f of t and a t. And then you tell me what the f of t is, which is the given function, right? So that is a limit as t approaches to 2. The t is, you have 40t minus 16t squared, subtract f of 2, then you have a 40 times 2 minus 16 times 2 squared, divided by t minus 2. The rule is you simplify everything. So you have a limit as t approaches to 2. And then this is 40t minus 16t squared. And then this gives me a 16 divided by t minus 2. And then to factor, okay, let's put the t squared first. So we have limit t approaches to 2. We have a negative 16t squared plus 40t minus 16 divided by t minus 2. Let's reduce the leading coefficient a little bit. So I am going to factor our negative 8. So factor our negative 8. We have a 2t squared minus 5t plus 2. And then use any technique you like to factor the 2t squared, the second degree, the quadratic equation. So we have a limit as t approaches to 2. We have negative 8, so factor that. You get 2 factors, right? Because that is a second power. So 2t minus 1 times t minus 2. Yes, the t minus 2 in the denominator is our biggest enemy. So now the enemy is gone. It is safe to plug in t equals to 2. So you plug in, you have negative 8 times 2 times 2 minus 1. What do you get? You have negative 24 feet per second. So this, we can call this the instantaneous velocity. Is negative 24 feet per second at t equals to 2. So we have a given function, right? Assuming that the given function is a curve, all right? So we have assumed that the given function is a curve. So let's say it's a second degree, we assume that we have a parabola. And then when t is equals to 2, we have a negative slope. So let's say at this point, t is equals to 2. This is the what is given. So that is the f of t is given in the problem. This is my displacement function. And then the f prime of t, I didn't graph the f prime of t. The f prime of t is a velocity function. When time is equals to 2, t is equals to 2, we have a point. What is the slope at this point? The slope at this point is, so we have a tangent line. The slope at this point is equals to negative 4 feet per second. So it's negative because the slope is of the tangent line is negative. So that will be all for this velocity problem. In the next problem, I will show you how to find the slope of any function at any point using limit. I see you in the last part.